So hope we're having a nice weekend. Good day, everyone. Hope we had a nice weekend. My name still remains Adejimo everyone, and welcome to the day 2 of the data analysis workshop. So today I'm going to be taking us on data analysis using the Python programming language. This is Python. I'm very sure the Python programming language is a very common programming language that everybody knows, even those that are not using the language itself, because it's very popular. So what is Python? So Python is a high-level multipurpose programming language. And when we are saying a programming language is high-level, it means that the syntax of that particular language is meant to be human readable. So a human can look at the syntax to understand that, okay, this is what this is all about before that particular code is now translated back to machine language for the machine to be able to understand and execute the commands. So this programming language, and it's only few programming languages that are actually multipurpose. So when we say programming language is multipurpose, this means that this programming language can be used in various fields, such as web development, data scientific computing, statistical analysis, robotics, automation, and a lot of fields. So you can use this Python programming language in various fields, which means to transfer that knowledge to other fields. So if you're a data analyst and you feel like you want to switch careers to web development, you already have understanding of this particular language. So you have no problem when you're switching careers. Same also applies maybe you're in web development, you want to switch career to data science or data analysis, you will not have any problem because it's still the same programming language, just some difference in some few applications or things like that. So the switch to careers is very easy once someone is able to know the Python programming language. So that's why it's called a multipurpose programming language. So why Python? Why would you actually use Python programming language? First of all, the thing is that Python programming language is open source. And when we say something is open source, it means it is free. So unlike software such as Excel, which is used for data analysis, it is not free. Excel is not free. We also have other softwares too, like Power BI now. Power BI web is not also free. So these are softwares which are not free. And when the software is not free, it's not everybody that can actually afford that particular fee. So for Python, it is free, and if you as a user have a feature that you think is going to benefit everybody that is using this particular language, you can contribute. Okay, I have something I feel like everybody will benefit from it, so we can contribute to it. But something like Excel now, you cannot actually contribute to Excel because Excel is closed there. Is with Microsoft, so nobody have access to that. So that's why Python is open source and it is free. And another thing also is beginner friendly. This is because it is very simple and easy to read. So Python programming language is very, very easy in the sense that it's one of the programming language that is taught to children at a very young age, but it is easy to understand, easy to read, and easy to write. The purpose, this I've already explained earlier on, you can use it careers. Once you know the Python programming language applied in this particular field, but you already have the knowledge of the community of users. So if you are in a particular, you don't know how to progress in a particular one, people online that actually help you. There are many tutorials. When you Google, a lot of results come out on a particular problem of Python. The first of the Google, you'll be able to get your answer because by someone else before. So the Python, and also we talked about arrays today. In fact, the Python. So now, if we use the Python programming language, so because in which it is used in other areas, if you want to use the Python programming language, you need to. Conda is an open source distribution of Python, and I use Python also in Anaconda. Let's say a data analyst, instead of together, bring all these packages together, people can be able to use this without installing a lot of software or a lot. This one single platform, you can be able to access various tools and various softwares which you can use in your work. It also has a collection of over 1,500 pre-built packages. Anaconda is the distribution that contains the Python, and it's not actually the main analyzing data with the Python. So the Jupyter Notebook. But first of all, the Anaconda, you can go to the Anaconda site today through the email to people, so you access Jupyter Notebook. So this is so run it. So
sorry to interrupt, but I think your connection keeps breaking.
Okay, sorry, let me check it. Is it okay now?
You have to keep talking to confirm, but it breaks intermittently as you speak.
Thank you. So Jupyter used in writing the Python code. So from the name Jupyter reports, I can also keep your codes too also in a notebook. So you can write your reports. I can also keep your codes too also in this particular notebook. And also it is easy to share with people. You can Jupyter Notebook. It's used for data analysis. Yeah, let me know. Please let me know if you did. So I was on Jupyter Notebooks. So Jupyter Notebook is the platform which you are going to be using to analyze data using Python programming. You can use it for data analysis, scientific computing, and machine learning. So with Jupyter Notebook, you can be able to share your codes to others to see your analysis either in form of a report, or you want to share the particular code using performing a particular work. So Jupyter Notebook is that particular platform we use as the data analyst that is using the Python programming language. So this is the interface of the Jupyter Notebook, which we are going to open later. But first of all, let me explain the interface. So this that you are looking at is called the code block or cell. So we call this the cell. So this is where the code is going to be run. So you can see a particular option here. So when you click on this drop-down arrow, you have two options, code and markdown. So markdown is used for writing reports, while code is used in writing your code for analysis. So you can also see the tabs we're having: the file, the edit, the view, the insert, the cell, the kernel, widgets, and help. So now I'm going to open the Jupyter Notebook. So if you want to access the Jupyter Notebook, just go to your, I'm very sure all of you have already installed Anaconda yesterday. So when you install Anaconda, you're going to see other applications that's installed with Anaconda. You'll see applications like Spider and Jupyter Notebook. So you go to your Windows startup and you open the Jupyter Notebooks. So this is the interface of the Jupyter Notebook. So this is what you are going to see when, as everyone opened this Jupyter Notebook.
Yes.
Yes.
Okay. So this is the interface of it. Okay. So this is the first thing you are going to be seeing when you open the Jupyter Notebook. So you can see, first of all, let's start with here. You can see 3 tabs. We have files, we have running, we have clusters. So these files is going to allow you to be able to see all the file directories on your PC. So I'm going to see everything, your documents, everything that is in your PC that can access it through this particular place. While when you click on running, you're going to be seeing all the notebooks that are currently opened. So currently now you can see I have 2 notebooks that are opened. You can see the document. This is the file part, the parts in which those particular notebooks are. So you can see it's showing me that these particular notebooks are open. And by clicking shut down, it's going to shut down that particular notebook. So now, what if I want to now create, yesterday in R, we are shown how you can create an R project. While in this situation, we're going to be creating a folder. So a folder is going to be connecting all the files that we are working with. So you click on this tab called new. When you click on this tab called new, you click on folder. So by clicking on folder now, by default, it is going to click. These are various folders which I've already created. You can see that they are empty. They're empty and they have not been named. So by clicking on new folder, it is going to give you an untitled folder. So I've already created previous untitled folder, and the current one I just created now is untitled 6. So if I want to name this particular folder, I'm going to click on this checkbox. So I've already clicked on the checkbox now. You can see I can click on rename. And by clicking on rename now, I can name it, let's just say Python projects. So I'm naming it Python projects, rename. Okay, so you can see okay, it was a Jupyter notebook I named. Sorry, it is the folder I'm trying to look for. Where is the folder? Okay, here's the folder we created, untitled folder. So we click on rename, Python projects, rename. So now I've already created a folder called Python project. So if you want to create a Jupyter notebook in this particular folder, we click on this Python project, we open it, you can see that it says this particular folder is empty. You click on new, then you click on Python 3 IPY kernel. So this is going to open a new, Jupyter notebook for you, a blank Jupyter notebook. As you can see, it is opening, so you can see it. So this is the interface. You can see our cell, the cursor is blinking on this particular cell. So this is where you're going to write your code. So it supports syntax highlighting. So if I'm to write, you can see it supports syntax highlighting, which means this is where you are going to write your code. So anything you're going to write here is going to be code. So what if you now want to write your report? Then you can now click on here. You can click on add. You use this button to add a new code block or a new cell. And if you now change this particular cell to a markdown. So a markdown allows you to be able to write sentences, which it is not going to detect as a code. So you can write sentences. Let's say you can just write a report. So once you write a report, you now on your keyboard, Control Enter. You can see it has already. This is a text we have already written on this particular cell. So this is the two type of cells that we have. We have a code cell and we also have a text cell. So this is the file tab. This file tab allows you to be able to create new notebook. You can also open a file from this particular file tab. You can make a copy. You can save as. You can also rename this particular file, or you can just click on this place. You can click on the default name. By clicking on the default name, you can change it. I can say my first Python project. So my first Python project, I've already renamed it. So by clicking on this place, you can also rename it, or you can go through the file tab. You can also download it as a report. If you already have a report which you have already done already, or have already conducted, these are the various files which you can download your notebook as. You can download it as a PDF, you can download it as a Python file, a raw Python file, any format which you want. And this is also the edit button. The edit button has a lot of things which you can use to edit the code you have already written or the text you have already written, or the cells in general. We also have the view tab. We have the insert tab, which allows you to be able to insert cells either above or below. So if I use the insert cell above, you can see it's going to insert a cell above this particular, above the previous cell I was in. If I also click on this particular cell and click insert cell below, so you can see it has already inserted a cell below the cell I was in before. So also have the cell tab also, which you can either run cells. The shortcut for running cells is Control Enter. So let me just type, for example, now 2 plus 2. So by typing 2 plus 2 now, Control Enter, you can see I have 4. So this is where the output, this is the output. This number that I'm looking at here, it means if I run it again now, you can see this number changes. So it's showing me the number of times this particular cell was run. So this is the input, INOUT. You can see this is also the output. So we also have widgets. We also have help. This is the help function. And here we have documentation to various libraries that are used in data analysis, which I'm going to explain later on. So here too also we have the save button for saving. You can see it. We also have the plus button for inserting a cell. It has already, this automatically inserts a cell for you below. We have here we have the cut selected cell. If you want to cut a particular cell and paste it, you can use the cut selected cell. So let's try this. So you can see it has already cut that particular cell. And we have the copy selected cell used also for copying. And this is the paste cells below. So that cell I just cut earlier on, I'm going to paste it. Now you can see I've already pasted this particular cell below the cell I was in. So if you want to move a particular cell up, this is the arrow, you can move it up, and this is the down arrow, you can move it down. If you want to run a cell, you can see it, you can use this button, or you can use the shortcut Control Enter. You can also use another shortcut Shift Enter. The Shift Enter allows you, let me use the Shift Enter here. Shift Enter. Shift Enter is going to run this cell and create another cell below. So by using the Shift Enter, it's going to run this cell and create another cell too below. So you can see by clicking Shift Enter, it has already run this one and created another cell below. So you can use that Shift Enter, that is the Control Enter, depending on the one you like. So let me go to the file, to this file. So now this is an example of a document. So I can see this example of a Python notebook. You can see the notebook is somehow looking like a report. So the code I used in designing this particular notebook is there. The output is also there. Look at the outputs. I can also see the text too. Also I've also written. Look at the text, the various texts I've written. So if I double click on this, you can see the details of this particular. Cells. So the first thing now we're talking about is Python variables. So yesterday we talked about variables so generally in programming languages, we use variables to store our values. So any value we have to put it in a variable, whether it is a data or it's a single variable, a text numeric variable, you just have to name that particular, or is the text or numeric value, you have to store that particular value in a variable. So without storing in a variable, the programming language, which is Python, is not going to be able to access that particular value which you want to use. So variables are containers for holding values, and variables are created by assigning a value to a particular name. So in Python, we use the equals to sign to, just like mathematics. Like I said earlier, it's very easy and simple to understand. Even a layman, by looking at it now, you know that, okay, this is what is going on here. X is equals to 5, Y is equals to hello world, and X, comma, print Y. You can see it, this is X, we are calling X, this is print Y, we are calling Y. So now just want to name a variable now. So I can just say Y now is equals to 7, Control Enter. So you can see that it has already stored this particular variable by showing this particular sign. So if I want to call Y now, I can either call Y by just typing the variable name or using print Y. So both of them works the same, print Y. But the advantage of this print Y is that if you want to print, because we are talking about cells in this particular place, you want to print multiple variables. Let me, for example, have 2 more variables, S is equals to 5 and A is equals to A is equals to 9. Okay, so let me just do it like this: A, X, and Y. So you can see now when I run the whole of this cell, only the value of Y was printed out. So this is one of the advantages of using the print function. By using the print function, I can be able to call all of them together. Print X and print Y. Okay, sorry. So you can see now using the print function, I was able to call all the variables together, 9, 5, and 7. So this is one of the advantages of using the print over just calling the variable names themselves. So I'm going to talk about the variable types later on. So for now, rules for naming variable in Python. So we have rules when we want to name variables in Python. A variable must start with a letter or underscore character. A variable name cannot start with a number, but can contain numbers or characters in it. And variable names are case sensitive. I discussed about the issue of case sensitivity yesterday. So when you are naming variable, one has to be very careful, especially in Python. You have to name this particular, when you are naming a variable, you cannot have variables which are the same spelling, but different cases. So one is lowercase and one is uppercase. One is lowercase and one is uppercase. There are 2 different variables, so that they cannot be the same variables. So now you can see these valid variable names now. We have one, my name is Ridwan. You can see this one is a valid variable name. You can also see this one is having an underscore in it. My name is equals to Ridwan. So when you run the whole of this now, I'm to run. So let me just run that of my name underscore. So you can see it's a valid variable name. So by running it now, it's going to print it out without any errors. Same thing also applies to all these other ones that we're having. This one also is starting with an underscore. This is a valid variable name. When I print this two also, you can see it's bringing out the, and this one also that is having a numeric value at the extreme end. And also this one too that is having an uppercase 2 in the middle. So all these are valid variables. But when you come to this particular cell, you can see we are dealing with invalid variables. And one thing that we even let you know that your naming is very wrong is from the syntax highlighting. You can see that this is a variable name normally is supposed to be having black color, but you can see that this is having green color. So here you are going to know that something is wrong. So when you run this, it's not going to give you the results. So by running to my name, I'm going to get an error, invalid syntax. So this is not a valid variable name. So even when you're even typing it, when you see the color is not matching, you know, okay, I'm having a wrong variable name. Same thing too also applies to this particular one, my, then hyphen name. You can see that when I run my, then hyphen name, you can see that I'm going to also be having invalid syntax. So you can see it's also showing a purple color, which means that from here, you know that, okay, this particular variable name is not valid. You can also have space between two, like my and name. Let me just use a new code cell. My and name. So you can see invalid syntax also. And you can also have a dot too between. So this is one of those symbols that which you can also use, my and name. So it's going to detect it like two variables. I'll explain later on why you cannot also use dots, because we have what we call methods. And these are what methods use. I will explain methods later on. And also, we can also start with this dot too. We cannot start a variable name with this particular dot. It's going to return an error for us. So what if you want to now assign multiple values? You want to assign multiple values to multiple variable assignments. You want to assign multiple values to multiple variables. So now, so let's say I have a particular variable called country. So this is the name I want to give this particular variable now. So this is country, and I have another variable name which I want to store a value in, which is states. And also I have, let's say, LGA. So I can do it like this now. So I can now assign all of this. All these are various or different variable names. I can now assign all of this now. I can say, okay, the first one now is going to be Nigeria. Then the second one now, I'm going to separate it with a comma, is going to be Lagos. Then the next one I can now say it should be. So when I run this now, I've already stored 3 values in 3 different variable names. So when I call them, when I call these variables, print states and print LGA. So when I run this, you can see that I have what's Nigeria, Lagos, and Oshodi. So 3 values have already been stored in 3 different variable names. Okay, what if I now also want to assign one value to multiple variables? I have a particular single value I want to assign to multiple values. You can also see what I did here too also. So I'm just going to use the equals to sign. This equals to sign is going to be passing. This is the initial. If you look at it now from the right-hand side now, you can see that this is our value. So let's say we don't, let me create a block. So this is our, if you look at it from the right-hand side now, this is this value we have. So this value has already been assigned to LGA. So now the value inside LGA is not going to be assigned to capital, and this particular value is going to be assigned to state. So in this process, now I'm going to have a single value has already been assigned to multiple variable names. So even if you have like 50 variable names, because this is the same procedure of assigning a single value to all these variable names. So we have comments too in Python. So comments in Python is also the same thing with comments too that we talked about in R. You use the pound symbol or the hash symbol. So comments are used for code explanation. If you want to explain code now, like just I say this is a comment, use the hash symbol. You start that line with an hash symbol, or you want to make your code more readable. So you want to make a code more readable, you want to just break down the codes, use comments, or you want to prevent the code execution. If I now have a code now, if I have a code 2 plus 2. So now when I run this now, Python is going to take this. It's not even going to take it. It's just going to take it as an empty line of code. So it's not going to run anything. Even if I store a variable name now using this particular hash symbol, it is not going to recognize it as a variable because it is already starting with an hash, which indicates it is a comment. So we also have multi-line comments. This is one thing also that is lacking in R. So multi-line comment allows you to write a long text in a code. You want to write a long text now, you can use the multi-line comment. So let's say, for example, now I want to write the quick brown fox jump over a lazy dog. So I'm going to use triple quotations. You can see it now. These quotations can either be single quotes or double quotes. So I can also use the double quotes. So this is it. I enter. So with this now, I can write a lot of text now. A lot of text. I can write a lot of text inside this word, triple quoting. Because this is something I cannot do using the hash symbol. If I'm to use the hash symbol now, for example, it's only going to recognize the first line as a comment. You can see. If the rest I'm going to be typing is going to be recognizing it as either a variable name or a value. So this is the difference between the multi-line comments and the single line commenting. So if you have something like a paragraph or a long text, you can just use the multi-line comments. And this multi-line comments is quotation marks, that is triple quotations, both at the front of the text and also at the end of the text. So now the next thing we'll be talking about is Python data types. So what are the various Python data types? So we have values can be stored in various data types, or let's say variables can be stored in various data types. So we have the string data type, we have the integer data type, the float, the list, the tuple, the range, dictionary, set, and boolean. So these are the various ways in which Python stores data. So the first one we're going to be talking about is the string data type. So the string data type is used for storing text. If you have a text that you want to store, you are going to be using the string. Your variable is going to be stored as the string data type. So Python will store your value as a string data type. You can see in this place now, print high. High is a text data. So Python is going to store it as a string. So now I'm having now two variables which I named. You can see how I used the multi-line quotations. So that if you want to write a long text, not only in commenting too, also even in storing a text, you can use these triple quotes too also. So if I use enter now, I can be able to store store a long text as a variable. So I store the name is equal to Mike. This is string data type. And here too also is a multi-line string, which I also stored as statements. So if I run this particular cell, like I say I'm having Mike, and I'm also having the quick brown fox jump over a lazy dog. So these are string data types. An element of a string can be accessed using square brackets. So now this is a variable that is stored called hi mom. So one thing also before I move on is indexing in Python. In R, indexing starts from 1. While in Python, indexing starts from 0. So if I want to now get this letter I from this particular variable, which I've already stored now, let me run this. This is variable A now. So I want to get the letter I. So this position of letter I now is position 1, not position 2. So I'm going to use 1. So you can see I'm already getting the value of I. So if I use position 0, I'm going to get the value of the first element, which is each. So unlike in R where it is starting from 1 instead of 0. So it's a very important thing to take note. In Python, the indexing starts from 0, not 1. And also you can use this square bracket just like in R to also use this particular square brackets to be able to access the elements of a string. So if I use 5 now, so you can see that the seventh element here, which is index number 6, is M. So this is the 7th element, but the indexing is 6 because the indexing is already starting from 0. So you can see that it is the letter M. So when I run this code now, you can see that we're having the 5th element here, which is M, the capital letter M, and we have also here the first element here, which the indexing is 0. So how do you now check the length of the string? So you want to check the length of the string, you use the length function. So by using the length function now, the length function on that variable we stored earlier on A, so you can see that we're able to know that, okay, we have 7 characters in this particular string. So now, if I have a sentence now, this is a sentence now, a variable, this is a sentence which was stored in the variable sentence, the quick brown fox jump over a lazy dog. And I want to now check, okay, is the word fox now inside this particular sentence? Or let's say now, if the word D is in what sentence? Sorry. Okay, so now it is returning a value of true for me. So which means that yes, the word D is in sentence. So what if I now say the word lion is in this particular sentence? So you can use you can see it is returning false, which means that the in keyword allows you to be able to check that, okay, is a particular word in this particular sentence or not? Is it in a particular variable you have, which is a string? Is that particular word in that particular variable or not? So you can use you can be able to use this particular in keyword. It lets you know that, okay, this particular word is in this particular variable or not. So a range of string can be indexed using the colon operator. So now, instead, earlier on, I was showing how you can index a single character. So what you want to now index multiple characters. So this is where I'm going to be using the colon operator. So I want to now index. So if I want to index just the fourth element. So which is a space. You can see it here. This is the fourth element, which is actually a space. So let me just make this 2. So earlier I was explaining about accessing range of elements in a particular string. So we want to access the range of elements now in a particular string. I'm going to be using the colon operator. So let's say in this our particular variable now, B, I want to access elements, this particular element here. So if you count it with the space, this is element 4 and this is element 6. So I want to access elements 4 to 6 now. So I'm going to say, I'm going to use the B. I'm going to use the square brackets. So I'm going to say elements, that is elements 4, index of 5. Okay, so let me use it before. So you can see 4 to 8. So now you might be wondering now, why is it that, okay, we index 4 to 8, but it's only 4, 5, 6, and 7 that is shown, because you can see a space now in this place. We're having space here. So when you are indexing a range, the digit that's going to be, that is the number you put at the end is going to be like, okay, this should not be this value and also not more than this particular value. So I say element 4 now to 8 is going to index the 4th element, the 5th element, the 6th element, the 7th element, excluding the 8th element. But if I want to include the 8 elements, now I'm going to say 4 to 9. So you can now see that the 8th element now has already been included. But the initial number which I gave is going to also include that particular number. So you can use the colon operator to be able to access, you want to access the elements in a particular range. So what if you index a string with a negative value? So when you want to index a string with a negative value, it's going to now start counting from the back. And when counting from the back, it doesn't count at 0. So instead of, if, for example, now this particular H and I now are having the indexing of 0 and 1, you want to count from the back, this one is going to be having indexing of 1. This is D. The lowercase d is going to be having an indexing of 1, while the uppercase, the lowercase a is going to be also having an index of 2. So it's not going to be counting from 0, it's going to be counting from 1. And for it to be counting from 1 and from the back, you have to use the negative indexing. So by creating a new block now, so I use the square brackets, negative of 1, sorry, negative of minus 1. So you can see now that I'm already having this letter D from the back. So using a negative sign on a particular number when indexing is going to give you the elements from the back of that string. So the next type we're going to be talking about is the numeric type. So in the Python, we have 3 types of numeric types. We have integer, float, and complex, but we'll be talking about integer and float alone, since most of the time we're going to be working with integer and float values. So integer values are values that don't have decimal points. So they're either positive or negative values which are not measured on a continuous scale. So they don't have decimal points, integer values. While float values have decimal points. So you can see here I'm having 2 values which are the same. I have 5 and 5.0. But when you now run this now, you can see that Python is going to print the type. So this first one, the class is integer, while the variable y, the class is float, even though they are the same number. But because of the kind of value I gave to each particular variable, Python has already automatically assigned the various numeric types to it. So what if you now want to convert a particular type to another particular type? So you can convert a value which is integer to a value which is float, and you can also combine a value which is float to a value which is integer. So you can see I already have, let's say I have a variable, I want to convert this particular variable now. So I can convert this particular number now, type 5, which is integer. So I can just say float 5. So when I say float 5, you can see now it has already returned 5 as a, it has already returned the integer 5 as a float. The same thing also happens when I use the integer function. It is going to integer 5. Let me give it 5.87. So it is going to truncate it. You can see it did not approximate it, it truncated it. It's removed all the numbers that were after the decimal point and gave us that initial, give us the initial whole number. So the next data type we'll be talking about is Boolean values. So any expression that returns true or false is known as a Boolean expression, and Boolean values are only 2. We either have true or we have false. So these are also data types too on their own. So they usually come up with comparison. So if you are comparing, let's say a particular number is less than a particular number, the output that you're going to be getting is going to be a Boolean value. Like in this example, now I can see print cat is equals to dog. So you can see that this particular string cat is not actually equals to dog. So we're going to be getting false. You can also see we have print 100 is less than 4. You can see that 100 is not less than 4. So we're going to also be having false. So these are Boolean data types. So let's say I put class now. Or type, sorry. I think this is type. Non-type. It's returning a non-type. Earlier on, we applied on the numeric data type. It's returned numeric or float. The next also have is Python operators. These are operators which you use in performing mathematical operations between variables and values. We have various kinds of Python operators. We have arithmetic operators. We have assignment operators. We have comparison operators. We have logical operators. We have identity operators. We have membership operators, and we have bitwise operators. So we might not be taking all of them, but we'll be taking the important ones. We have the first one we're talking about is arithmetic operators. So these are operators which are used in performing mathematical operations. So if you have an operation that you want to perform a mathematical operation in a data, or you have some values which you want to perform mathematical operation with, use the arithmetic operators. And the arithmetic operators we have, the first one is addition, which is just the plus sign. The second one we have, when I run all of this, I can see the output of the first one, which is 10. This is the addition operator. The next one is the subtraction operator. The next one is the multiplication operator. The next one is also the division operator. Why this one is called modular division. So in modular division now, you get the remainder. You can also call it the remainder division. So when you divide 9 by 2, so 2 is going to go into 9 4 times, remainder 1. So that remainder you have if you want to get that remainder now, this is the sign you're going to use. So you call it remainder division. If you divide 4 by 2 now, for example, so you can see we have 0 because 4 divided by 2, we are not going to be expecting any remainder. So we are going to be having 0. So this is called the modular division. It's the percentage sign. Why raised to the power? In the raised to the power sign, the raised power sign is different from that of R. So in here we use double asterisk. You want to raise a number to a power. So if you want to raise 4 to the power of 2, use the double asterisk. Why this double slash is called the integer division. So now, unlike this percentage sign we used earlier on to get the remainder, here we're going to get that particular number itself, excluding the remainder. So when we say 9 integer divided by 2, we're going to be getting 4. So same thing also if I use say 11 integer divided by 2, we're going to be getting 5. So 2 is going to go into 11 5 times, remaining 1. So if you want to get that particular number, use the integer division. The next operators we have are called the assignment operators. So use this particular operators to assign a value to a particular variable name. So we have already used the equals to sign. We also have another assignment operator called the plus equals to. So you can see here now in this particular cell, we're having y plus equals to 5, which is also the same thing as typing y is equals to y plus 5. So instead of typing in this place now, I have already a variable stored as y already. So I have a variable stored as y is equals to 2. So now I want to change the value of 2 now to another value, but by adding what? A number to it. So instead of saying y is equals to y plus 3, so this is just like a shortcut. I'm just going to use the plus equals to sign as what? 3. So they are going to give me the same answer. Either I use this one or I use this one, it's also going to give me the same answer. So this is just a shorter form of writing this particular line here. So instead of saying y is equals to y plus 3, you can just say y plus or equals to 3. So this is called the addition assignment operator. So the subtraction assignment operator also works the same thing as the addition assignment operator. They both work the same thing. Instead of just saying z is equals to z minus 8, I'm just going to say z minus equals to 8. So which means that, okay, the initial value I have of z, you are going to add 8 to it and replace that particular value in this same variable called z. The same thing also is the multiplication equals to operator. It works the same way too. Also, I also have the division assignment, the multiplication assignment operator. Then the next one is also the division assignment operator. So these are the assignment operators that we have. So these are the various assignment operators that we have in Python. So the next one we also have is the comparison operators. So if you want to compare two variables together or you want to compare two values together, use the comparison operator. So you can look at it, you can see this now, 5 is equals to 7. So we want to check whether two numbers are equals to each other, use the double equals to. So with the single equals to, that one is an assignment operator. So I'm going to use the double equals to, which is a comparison operator. And this not exclamation mark is used, which equals to is used for not equals to. So you can see by running this cell now, you can see the result of this particular line here, where is false. And also the same thing applies to this one, greater than, less than, greater than equals to, and less than or equals to. Also, we have with the logical operators. The logical operators are 3, the and, the or, and the not. So this is, if you are normally with the and operator, you can see that x is less than 5. We have x less than 5 and x is greater than 5. So let's say I have a variable called x. Let me call x to be 2, for example. Now I'm going to call x to be equals to 2. So now x is already equals to 2. So we know that 2 is less than 5, which is true, and 2 cannot be greater than 5, which is false. So when you use the and operator, a true and a false is going to return a false for you. Why this is the opposite in the or operator? If I'm to change this now to the or operator, a true and a false is going to return a true for me. So you can see the or operator is returning true. So these are logical operators, and we have the not. So the not is going to return the opposite of that particular Boolean value that was returned. So x is less than 7, which is 2. But now when we use the not operator, we're going to be getting what's false. So this is like the complement of the Boolean value we got by running x is less than 7. Then we have the membership operator. This is used to check whether a particular value or a particular value, a particular variable is also in another variable. So here we have this value each, this string each. I also have another string here too. This is my age. So you can see now I'm trying to check whether this age now is inside here. And I told you it's case sensitive, which means that it is going to return a Boolean value of false for us because we're having upper age starting with uppercase here. While in this sentence here, or in this phrase, we're having lowercase age, which means it is false. This particular word is not in this particular phrase. Next to also we have print 5 in this particular list. We have 4, 5, 6, and 7. So you can see that 5 is in here, so it's going to return a Boolean value of what? True, false. So the membership operator here is the in. So the in and the not in are the two membership operator we have. So the not in is just the opposite of this in. So you want to see if I is not in here, which is returning false for us, that I is not in this particular phrase. I, mom, and dad. The next data type we're going to be talking about is lists. So the data types we'll be looking about further on now after this. Once we have talked about the Boolean, the numeric, and also the string. So we can also call them as data structures because you can use a storing more than one data value in it. So if you have multiple data values, you can use it to store it using this particular data structure. So there are also data structures in Python. So the first one here is lists. And they say, and we have that lists are data structures that are mutable or changeable. So which means you can change the elements of a list. So if you have a list now here, like here we have states is equal to Kano, Abuja, Lagos, and Ogun. So this is a list. And a list is created using the square brackets. You can see it here. You create a list using the square bracket. I can add another element to here. So you can see I can add another element to. I can add another element to in this particular list. So lists are created using square brackets. But one unique thing with lists is that you can change the elements that are inside a list. So even if you have 100 elements, you can change a single element inside. So for you to change the element in a list, you need to know the particular index of that element. I can also store different data types inside a list now. I can put a number in this place now, 1, 2, 4. And if I run it, I'm not going to get an error. You can see all the values of my list. So it's not necessary that your list is going to contain a character all true, a string all true, or a numeric all true, or a Boolean all true. I can add a Boolean to this place. So one thing I also want you to notice, you can see the color is also changing for various data types. You can see for the string we're having red, for the numeric we're having light green, while for the Boolean we're having darker green. So you can see that you can put various elements of various data type inside a list. And the items inside a list are ordered. What I mean by ordered is that that means they have an index number. So if you want to get the item, you want to get Abuja, for example, now, you're going to use the index number belonging to this particular Abuja. So which means another element inside this place. Lagos cannot be having the index element of Abuja, and Abuja can also be having the index element of Lagos. So now what if I want to get from this state variable now, I want to get the element Abuja. So I'm just going to change this to 1. So you can see I've already gotten Abuja. I can use my colon to also, I want to get from Abuja now to Ogun State. So I'm going to say 1 to 3. So it's going to return, okay, from Abuja to Ogun, I'm going to say 1 to 4, sorry. So it's going to return 3 elements for me, excluding the range I gave, that is 4. So it's going to give me the element 1, 2, 3, the element with index 1, 2, and 3. Because I told that the indexing starts with 0. So if I put 0 to 4, I'm going to get Kano to Ogun State. So this is where you can see how the color also works. You want to select the range of elements in a list. So what if I want to now change the elements now in a particular, if I want to change the elements now in this list. So I want to change this Kano now. I want to change it to the number 5. So I can just come here and say states. So Kano is having an index of 0. So I can say states is equals to 5. Then I'll now call the states variable. So you can see now it has already changed the elements from Kano to 5. So that's why they say a list is mutable, and which means it is changeable. You can change the elements of a list. You can change all the elements in a list. If you want to check for the length of a list, use the length function. You can see the length function here. So our list now is containing 8 values. So which means that you can want to check the length of a list. So you want to say, okay, how many elements is my list now? Is in my list now? You can see that this list is having 8 elements. So you can also check what type of a variable. Like now, I just check the type of my list. That is the list, this particular list here. So I can get it as a list. So you want to check the type of a variable now, you just use the type function, you get, okay, that this is a list that I'm dealing with. The next data type now is called the tuple. So the tuple they are also similar to the list, except that in tuples, we use round brackets and not square brackets. So in tuples now, instead of using the square bracket, unlike the list, we are going to be using the round brackets. And they are not immutable. They are immutable, sorry. That means you cannot change the values. Unlike the list now, I cannot change the value of a tuple. So this is a tuple now you can see. And they also contain different data types. You can see now I have a numeric data type, I have a string data type, I have a Boolean value, I also have a tuple in a tuple, and I also have a list also in a tuple. So these are different data types which I have. So when I run this now, you can see the tuple I am having now. Now let's say now I want to. So let's see. So you can see now I can also index the values in a tuple. So this makes a tuple ordered, which means that you can index the values in a tuple. But what if I want to now change this particular value now, which is an index of 2, which is this Boolean value? I want to change it now to 5. So you can see it is returning an error. So that is why a tuple is immutable. You cannot change the values of a tuple. Once you have the values in a tuple, you already have those values there. So if you want to change the values in a tuple, you just have to create another new tuple, or you come and add it directly in this place. So I can add, if you want to change the values, you can just change it from that initial tuple. I can just change it now here to 4. But you cannot change it using indexing, just like we did in the list. You can also use the length function to check for the length of the tuple, which is 5, as you can see we have here. The next data type also are sets. So sets are used to store multiple items to also, just like in a single variable, just like we have in the list and also in the tuples. In the sets, they are not ordered, so you cannot index. So this is going to return an error for us, unlike in the lists and in the tuple. And also sets are created using curly brackets. So lists are created with square brackets, tuple are created with round brackets, while sets are created with curly brackets. Sets can also contain various data types, whether you have a list, you have a numeric data type, or you have a string data type. And duplicates are not allowed in sets. So what I mean by duplicates are not allowed in sets, if I say age, I'm going to be adding 2 values now, which are the same. So you can see now it's going to return a single value for me. So a set doesn't allow duplicates. So let's check for the length now of this particular set and see. So you can see now it is returning 5. Why initially I've already stored what? 6 values in it. So which means even if you have to have this value repeated 100 times, it's going to return it as a single value for you. So a set doesn't allow duplication. So you cannot duplicate a value in a set. You can't also change the items in a set, just like in the tuple. So you cannot change the items in a set. So if I'm to say my set now, let's say 4, I'm going to be having 5. So you can see that it is returning an error for me. So you cannot change the values in a set. So once those values are there, they are already there. And I told that also the set is not ordered. It's going to return an error. You cannot index it. So you can see that when I run this particular cell now, it is not going to index, it's not going to give me the value of that particular cell. So you cannot index in sets. So the final data type I'll be talking about is the dictionary data type. So the dictionary data type is used to store data values in key value pairs. So just like a dictionary. So in a dictionary data type, you can be able to give a value a name. So it's just like a form now. That's how the dictionary data type looks like. So if you look at this particular dictionary data type now, it stores this value dcomp as name. So this is the key. If I want to access this particular value now, I'm going to be using this. It also stores this particular value 19 as age. It stores this particular value male as sex. So please, you should not be confused with this and this. This is the actual value, while this is just the name of a value. So it's like you're giving this value a name. So let's say, for example, I'm going to be having multiple names here now. Let's say I'm going to be having another one called, let's see. Okay, second name. So you can see second name now is going to be Amanda. So you can see now, this is also another name I have. So instead of just writing all the names like that, I've already given it, okay, this is the name, and this is also second name. Then we also have the age, we have the sex, the male, and this is the marital status single. So now, in this dictionary now, we already have the key, we have already the keys here, and we have the values here. So if you want to access this particular values, we are going to use the keys. So the dictionary also is created using the curly brackets. As you can see, the curly brackets here. The dictionary is created using the curly brackets. So by the time I want to run this my dictionary now name, you can see now it's going to return Jacob for me. If I'm also going to call it by the second name now, I'm going to call it by its name. It's returning Amanda for me. And these items can also be changed now. You can see I can change this name now from Jacob. I'm going to change it now to John. So you can now see the dictionary now. I'm having John instead of Jacob. So you can change the items in a dictionary. And dictionary does not also allow duplicates. So you can see here, duplicates cannot be allowed in a dictionary. You can see here now, you cannot have two different keys, name and name. So if I'm going to run this now, it's going to return invalid syntax for me. So you cannot have duplicates, you cannot have duplicated keys in a dictionary. So these are the data types that are in Python. There are also other data types, but they are beyond the scope of this particular class. So the next thing I'm going to be talking about is how we can analyze your data in Python. So if you have a data you want to analyze, how you can analyze it, and packages you can also use to analyze it. Packages are going to be using to analyze that particular data. So I don't know, before I continue, is there anybody that have questions on what I just talked about now?
I might need to take you very far back. That's line 81, where you did
Sorry,
Z is equal to 8 and Z is equal to Z minus 8. Can you hear me?
Yeah, I'm hearing you.
Yes.
So Z equals to 8 and Z was equal to minus 81.
Yeah, this place, right? This place, right? Is it this place?
Yes. Yeah.
What's the
Yes.
problem
So
here?
why is it returning minus 8 as output?
Okay. So here now I store the value as Z. So let's run this. So this is the value 8, right?
Yes.
Okay, the reason why it's returning minus 8 as the value is because I've this particular line I have now already stored it at 16. Sorry, already, 8, I stored it at 0. So when I run this line now, okay, let me remove it again. Let me do it like this. So when I run this particular code now, I'm going to be having the value of Z as 0. So because it's the same thing also as saying Z 8 minus 8, right? So when you now run this particular line now, it's now going to become 0 minus 8 because Z has already been stored as 0. So that's why we're having minus 8 there instead of 0.
Okay, so
the
dash
problem that
equal
actually
to 8
occurred here
is the same thing as 8 minus 8.
Yes, Z minus 8 equals to 8 is the same thing as 8 minus 8, exactly. So what happened earlier on was because you are already on the same code. They are already on the same cell. That was why. So when Z was already stored as 0, they now took the initial value of 0 and it subtracted 8 from it and now returned minus 8. So if I'm to return it now back here, so I'm going to be getting minus 8. The value has already changed here. You can see it, right?
Okay.
The value has already changed here. So when it's going to use that particular value now, it's going to be returning minus 8. So normally that's supposed to even be in different code block. Any other question?
None from me. Thank you.
So I think I'll go to the data analysis suite. I'll go to the data analysis part. Okay. To be analyzing that particular data we talked about yesterday, which is the motorcycle sales data. So, but before we go now, we're going to have some something also I did not mention earlier on. Let me go to the. Let me go to the Python. I think this is it. Okay, so now this is our Jupyter. This is the home page of our Jupyter Notebook. So we have packages in Python that we use for data analysis. So some functions are not available by default. That's by installing Anaconda and your Jupyter Notebook. The functions don't come like that. So you just have to install them. It's just a single line you run, and those packages are going to be installed on your PC. So, but you need to be able to access the web terminal. So by clicking on this new button, you click on terminal. So when you click on terminal, so you can see how we have here, this Windows PowerShell. You can access the documents and files in your system from this place. But I'm not going to be doing that. Here, we just want to install a package. So I'm going to be using the NumPy, Matplotlib, and also Pandas packages. So if you want to install these particular packages, use the conda install command. So conda install pandas.
So mine does not have that option of terminal. I have code, markdown, raw, NB, convert, and heading.
Okay. No option of terminal at all?
No.
Okay, let me go here and see.
Oh, sorry. I've seen it. Thank you.
You have seen it, right? Okay. Okay. Yeah. So the first package I want you to install is NumPy. So this is the first package. This is just conda install. This is just the code to install any package. So after conda installed, then the next will be the pandas. Pandas, you can see, use this particular code. So you are going to be using conda install for all the package. So conda install, then the package name. Then the next is going to be matplotlib. So I already have it installed on system, but still running it is going to update the previous one you have already on your PC. So this is just the command you are going to use to install the package you are going to be using now for the next session.
Hold on. Okay, I'm done with
Any
NumPy.
problem?
I'm done with NumPy. So the next is to install.
Okay. Anybody having problem installing packages? Let me know, please. It's a quick one. It's not going to take long. So
yeah. So after finishing with NumPy, it says proceed, yes or no.
Yeah, just on your keyboard, just type Y. On your keyboard, just type Y.
Okay, download it. All right. So the next one is conda.
Next is going to be pandas. This is the spelling of matplotlib too, also for the next.
You wait till it's done by turn. Matplotlib.
So I think why is installing in background, I can also explain. I don't know, is there anybody having problem with installing the packages? This code block now, as you are looking at it now. So now these are the packages we use, NumPy. So you want to be able to access this particular documentation or help based on these packages, you click on the help, you can see their documentations. But by clicking on this, it's going to take you to the documentations. So here you can get details about this particular package.
The matplotlib
pandas reference, you can see the matplotlib, you can see the NumPy. So now import NumPy as MP, import pandas as PD. So this allows you to be able to use this particular package. So import NumPy as MP. So why you are importing NumPy as MP is because this is what you're going to be using throughout as MP and PD. So any value you give here is what you're going to be using. You're going to see it now. You can see for us to be able to read the data, we're going to be using the code pd.readcsv. So this is the function that allows you to be able to read your data. So once your data is in the same file as this particular Jupyter Notebook that you are on, so this particular file now is stored in the same place that this Jupyter Notebook is stored on. So by running it now, it has already stored my data as a variable called sales. So this pd.readcsv is from the pandas. So if I'm going to put import pandas as p instead of pd, I'm going to be using p instead of pd in this particular place. So now I can view my data now using the head function. So sales.head. So you can see now I've already gotten the first 5 rows of my data. So you can see the data, this is the same data we discussed yesterday, date, warehouse, client type, and so on. If you want to get the data types of this particular data, use the D types, but this is not a function, so it doesn't take any value. So by running the sales.d types, you can get the data type of each particular column or each particular variable in this particular data we are dealing with. So you can see now we have dates, which is an object, warehouse object, client type object, product line object. While you have quantity, which is integer, unit price, which is float, total, which is payments, and total, which is float, and payment, which is object. So it stores the characters as objects. The D type is object. So once you want to get the shape of this particular data we're dealing with, you want to get the number of variables and the number of rows. So you use the sales.shape. So when you run the sales.shape now, you can see we're having 1,000 rows and we have 8 variables. So you want to get the column names, you use the sales.columns. So you can see this dot sign, what it means here. It allows you to be able to use a function. That is why you cannot store a variable name. Earlier I explained I cannot store a variable name as dots, but you can use underscore, but you cannot use the dots because this dot is used to be able to access a function. And these functions are also called methods in Python. So by using the sales.columns, I'm able to get all the column names. You can see all the column names here: date, warehouse, client type, product line, unit price, total, payment. So a quick one here, you can look at this, you can see this, that these names are already stored as a list. So I can access the value of these particular names now. So by using 5, you can see that I'm already able to access what? Unit price. So from the square bracket, you can be able to know that these particular names of the variables in this data are already stored as a list. You can see the square bracket. So now I want to get the first 5 rows of a column by name. So if you want to get the first 5 rows of a column by name. So let's say now the column of client type, we're going to use the square bracket to access it, client type. So this is our client type now. We are going to be using the square bracket to access it. And we're going to put the name of the variable in quotation marks. Then we'll now use another square bracket too. Because after, okay, let me just run this. It's already giving us, as you can see, it's already giving it to us as an array. So if I want to access the first 4 or the first 5 now, just say 1, 0 to 6. So you can see now. So you can see now I've already gotten, these are the first 6 rows. I've already gotten the first 6 rows. So first of all, I indexed the variable name and also indexed the column, I used the row indexing to get the first 6 rows. Same thing too also applies if I want to get the bottom ones too also, once I know the indexing. So I want to create categorical ranges for numerical data now. So if you want to create categorical ranges for the numerical data, we use the pd.cut function. So the pd.cut function, you can see first of all now, sales total is going to take the column, total for us. So when you run sales total, you get the column total. So when you get the column total, it's now going to break down this column total, you can see into 10. You can see 10 intervals we have here now. By using this value of 10, if I use 5, you can see it has already broken down into 5 groups. You can see 1, 2, 3, 4, and 5. If I use 20 now, it's going to break it down into what? 20 groups. So you can see this dot here means that what there was other groups too also that have not been what listed. So this is just used for categorizing your data. You can also call this binning at times. So you can call it binning. You want to bin your data. So you have numerical values that you want to categorize like age now. So this is where you can use this pd.cut function. So this is how you create a categorical range for numerical data. And now also, you can get the value counts of the ranges above. So you want to get how many of those particular values, because we index total here, sales total. So we want to see how many of those total prices fall in this particular range. So when you run it now, we use 20 categories. I change the categories to 20. So when you now run it, I can see that, okay, for each particular category, you can know how many of these observations or how many transactions fall in each particular range. So for the initial one is 390, 291, 117, and so on. So now I want to index the columns of the first row now. So there's this function we call iloc. So we have two of them. We have iloc and we have loc. So it's just the same thing as location. So the iloc allows you to index a column name by their index value, while the location allows you to use the name. So when I use sales.loc now, sales.location. So now I have an observation of, I have an observation 4 now in my data set. I want to know the details about observation 4 now in that particular data. So the iloc is going to be 4. And this column means that I'm going to be selecting all the columns in the data. So the columns are on the right, while the rows are on the left. So when I run this now, you can see now this is for observation 4. So what if I now say 4, what is it, 3,4. So you can see now I only selected what, 2, I only selected 2 columns in this place, 3 and 4, product line and quantity. See, this is the 4th column and this is the 5th column. So I know it might look a bit confusing because the indexing starts from 0. So what you'll be looking at there will not be what you're using as the indexing. So, but you can use the loc function, which takes the, so this one takes the variable name. So you can see that it always gives me the total. So for observation 4 in my data, I'm getting the total of it. So what if I now want to get all the details of it? I'm going to use the colon operator. So you can see also the same thing. So just the difference between the iloc and the loc is that the loc takes in the variable names while the iloc takes in the indexing. Now, order the data by the, how can we order the data by a specific column now? We want to order this data by a specific column. So we have sales total. So we want to say what sales total, we're indexing the total, we're selecting only the total, then sort values. So you can see it's going to start from the minimum value, which is 10.35, to the maximum value, which is $2,547. And also you can also sort the data by a column and obtain a cross section of the data. So if we sort, let's say for example now, we want to sort the values of total, I will say ascending is equal to false. So by running this now, let me create a block here. So take data. So you can see that this can see that this data now is sorted by total. So you can look at the total now. Ascending is equal to what? False. So which means it is descending. So you can see that this is the maximum total and this is the minimum total, 10.35. So it has already sorted the whole of this data. So initially now we're having the data, you can see the indexing of that, of those observations. You can see it has changed from 774, 704. So it's already indexing by the total. You can also do that by the quantity. You can just change this to quantity. And I run it. So you can see that the quantity is starting from 40. It's going to be starting from the maximum value. If I use ascending is equal to true, it's going to give me an ascending order, starting from the minimum value of quantity to the maximum value of quantity. So now I can also get the value count of all columns. If I want to get the value count of all columns, so here now I'm going to be having sales, warehouse, those value counts. So you can see now I can get the value count of all the values that are in that part, or all the values in that particular column. So in warehouse, we have 3 factors now: central, north, and west. So there are 480 central warehouses, 340 northern warehouses, and we have 180 western warehouses. The same thing too, you can also apply to any other variable. You apply to product line. Product line. You can see now we have the number of items under each particular product line. You can use this value counts function to get that. So you can also get the unique value of a column by name. So just like now, you can just see a data now, like that product line, you will not know how many product lines we have. So by using this unique function now, you can be able to get a list of all the product lines in that particular data. You can see it has already been stored in something called an array. So this array is another data type, but it belongs to the NumPy library. So the NumPy library uses the array data type. That's why you can see that this answer was stored as an array. So the array is also similar to a list. In fact, they have similar properties with the list. I can also index an array just like the way you indexed a list. If you want to get also the unique, I can also get the length of this particular array now using the length function. So what if I want to index into a column and get the first 4 rows? So I use the square bracket. So by my left-hand side, I'm going to specify my rows. If I'm interested in 0 to the 10th row, then also the total. I can also include so let me give total here and payments. So you can see now I can get the total and also the payment. So this allows me to be able to select or filter the rows from my data. So with here, I can say, okay, I'm interested in just 2 rows from this particular data, or I'm interested in just 3 rows from the data. So using the log function, you can use the variable names, while the ilog is if you want to use the indexing of this particular data. So we can use the describe function to get a description of our data, just like the way the summarize function works in R. So but this only applies on the numeric variables. You can see we have only 3 numeric variables in this particular data set. We have quantity, we have unit price, and we have total. So we're not going to get any summary of the character variables. So we get the count, the mean, the standard deviation, the minimum value. We also get the quartile values, and we also have the maximum values. So use the describe function to get a description of your data. So please, it's also important to take note that throughout we'll be using, you can see we'll be using the sales, then use the dots. We also use the function we're interested in. So this is like telling Python that, okay, this is the variable I have. They're going to be using this particular function for this particular variable. So the dot cannot be the variable and the function together. So we also have a cross tab. If you want to create a cross tab, use the cross tab function. The cross tab function belongs to the pandas package 2 also. So let me just copy this. So pd.crossTab, you can see. So I want to create a cross tab of warehouse and sales. So warehouse is going to be on the column. Can you see why client type is going to be on the row? So you can see a warehouse now. And this is a count of, you can see it is counting how many items were bought in the central warehouse and were also bought by retail clients, which is 371. We also have the number of items that was bought by at the central warehouse and by wholesale clients, which is 109. So this is the function you use when you want to create a cross tab, pd.crossTab. So this PD is the pandas library. We also want to get the subset of the data now. So now so this is where you can see a combination. This is where you can see how we combine the operators we discussed earlier on. So this, let me start with this. So you can see now we are looking for items that are greater than 1,000. So which the items that are having a total price greater than 1,000. So you can see it has already checked the whole of our data and it's checking each row to see if the item is greater than 1,000. And so returning false for items that are not greater than 1,000. So now we're not going to be using that. Okay, we already have items now that are greater than 1,000. Then we need these particular items now. We should also check for items too that are bought at the central warehouse. So I'm going to be having and. So let me copy this. So let me put the brackets here. And we run this. So it's going to check for each particular row now to see the items that are greater than 1,000 and also bought at the central warehouse. If I'm to change this now to or, the or sign is this. The or sign is going to check for items that are greater than 1,000 or bought at the central warehouse, which means it's not necessarily an item that was bought that is greater than 1,000, but is not bought at the central warehouse can also fall in this list, or the item that was bought at the central warehouse is not greater than 1,000 can also fall in this list. But the and is more strict in the sense that it's only going to check for items that are greater than 1,000 and also items that are bought at the central warehouse. So all this now, we're now going to put, we're going to now index all these values now. Using sales, square brackets. So you can now see this is a data on its own. So this is items that were greater than 1,000 and were also bought at the central warehouse. So this is the data set for it. But because the data set is much, we can use the head function, which by default returns 5 values for us. You can see we can use the head function to be able to now get all these details. So this dot allows you to be able to be passing more functions to your data. You can be passing more functions with this dot that we are using. So you can also use dot and apply another function to this particular code that we're already written to get more insights from your data. So we have the group by function. So the group by function allows you to be able to group particular variables together. So let's say we want to now group the warehouse. After grouping the warehouse, you want to group the payments. Then you now have to get the average, or let's say the sum. You want to get the sum of the sum price of the items that were bought in that particular warehouse. So I can just change this to sum. So I'm going to get the sum of all items that were bought by different payment method and also under each particular warehouse. We have to change this now to client type. You can see now we have 2 client types, we have retail and we have wholesale. So this is also something you can see now, which allows you to know that most of those that bought on wholesale was transfer, because on wholesale, the amount is going to be much, so it's usually through transfer. So there was no cash and there was no credit card. So you can see it was all through transfer. Under wholesale, we don't even have anybody that bought using cash and credit card. You can also use the mean function. It's going to get you the mean. You use the mean, it's going to get you the average total sales that was made. Then here now we have we want to visualize our data. We want to perform data visualization. Though we have data visualization libraries like Matplotlib and Seaborn, but Pandas 2 also has its own little visualization function, which you can use for performing quick visualizations. Like in this cell that you're looking at now, we use the sales. We have passed our warehouse, sales.warehouse.value count, to plot a bar plot for us. So we're going to plot the warehouse. Okay, let's say now I want to plot the client type. So I'm going to say value count. Then dot plot kind is equals to bar. So you can see now, I just plot for the client type. So what you just told Python to do now is that, okay, this is my data and sales. With the dot function, I'll pass it. I want to plot a visualization of this particular variable called client type, but I need to get the value count of it. So it's going to count each row. So how many transactions were made under retail, how many transactions was made under wholesale. So then after counting, then plot a bar chart for me by giving these arguments kind is equals to bar. So when you go to the reference of these particular packages, you see the functions, and you can also see guides on how you can use these particular functions and perform your visualizations. So it was what I did here that you can also use here on the warehouse and also on any other categorical data which you have. And in this place, I performed a much more complex one. So here I grouped it. I grouped the payments by total. So you can see this is my sales data. I use the group by function here. So after grouping by payments, then by total. So I got the total transaction for each payment. So after getting the total transaction for each payment, then I use the aggregate, the aggregator function. So this is a NumPy. This is where the NumPy comes in place. I'm going to use the np.sum, which is going to sum all the transactions under each payment because I've already grouped the data by payment. Then it's now going to plot a bar chart. So by plotting a bar chart, you now get something like this. So you can see it. You can see now here, this is the total transactions that was made under each particular payment system. So if I also change here to warehouse, so I can also get that for warehouse too also. So these are just some of the few things which you can use to analyze your data in Python. You can use to analyze your data using Python. So throughout here, we are just using the pandas library. It's only in this place we use the NumPy library. You can see the np.sum, which I used in this place. Then also this matplotlib inline that we used allows you to be able to put your plots in this notebook. If you don't have this code, code run in your Jupyter notebook, then any plot that you plot is going to be showing outside this Jupyter notebook. It's going to be showing on a new window. So I'm not going to be having it under your cell. So that's why we use this particular line called this percentage matplotlib inline. It allows you to put your plots or display your plots to be displayed in your notebooks and not in a new window. So if you want to check more about these packages, these are the references, the pandas reference. This is the SymPy, the matplotlib. In fact, that's why in the Jupyter notebook, they put the major packages that are usually used, and also have the Python reference to itself. If you want to check help on the Python, then we have NumPy, we have SciPy, and we also have the pandas. So that is all. I don't know if there's anybody that have any questions based on what I've already discussed. So is there any questions?
Okay. Thank you so much.
Sorry, though we not use the matplotlib, so those having problems with matplotlib should not worry, but hope you still follow. Even though we not use the matplotlib, we only use the pandas library. I can see it here. Okay, so someone said he has already installed all. So this is it. So conda install NumPy. So let me just type it here. Maybe I'll save it with the code. Okay, sorry. So this is conda install NumPy, conda install pandas, conda install matplotlib. So these are the three packages that mostly, in fact, are majorly used in data analysis, these three particular packages. So if you have it installed on your PC now, you don't need to be installing it later on in the future. So this is just it, conda install NumPy. It's easy, you just go to the web terminal in Jupyter Notebook and you type in these commands, conda install NumPy, automatically it will install for you. Next time you run these commands, go to update the previous ones you had earlier on with the latest versions. So I don't know if, so that's all for this particular session.
Okay.
Does anybody have questions?
Okay. Okay, thank you so much, Ridwan. Thank you for this wonderful session. I believe everybody is really, really glad we had this session and it's been interactive. Thank you to everybody that has joined so far and stayed till the end. So I've dropped the email that you can contact us on if you want to inquire about our classes or any program you want to join. We have classes on the data analytics. We have those for the Scrum. If you're looking into Scrum Master, product owners, just get in touch with us through the email or our website. We'll be able to respond to you. So if you have any question, kindly drop it in the box or you just signify and ask the question so far. Okay. Okay, so thank you so much. So this will be where we'll draw the curtain on the workshop, and we look forward to you joining us next year. And we wish you a wonderful holidays ahead. Thank you very much. So it's bye from Business Data Laboratory here. Thank you, Ridwan. Fahida, thank you for joining, and Robinson,
Thank you, everyone.
very much. So that will be a bye-bye. Thank you, Stanley. Thank you, everybody. So thank you very much. So to be a bye-bye from here. Thank you.